Now we can check out where n is 3, that is n equal to 3 variables. We can get total number of bits as 2 raised to n minus 1. That is, here we are getting from 0 to 7. Okay, so if we put n equal to 3 here, 2 raised to 3 minus 1, which gives 8 minus 1 is equal to 7. Just we can see, check out 7. That is, we are getting the number of bits from, or number of expression from 0 to 7. So the same we can check out for the sum, that is 0 plus 1, which gives 1. Again 1 plus 0, 0. 1 plus 0 is 1. So we get the sum as 1 and the carry is 0. So moving on further, now let's check out for this step, which is 4 plus 1, 5. That is 4 plus 1. This is the decimal equivalent for, binary equivalent for decimal 5. So if we work out the addition for these 3 bits, 1, 0, 1. So let's start with a plus b. 1 plus 0, the output gives 1. That is, the sum is 1 with carry 0. Okay. Now that sum of a plus b is added to the carry in, that is 1 plus 1. So 1 plus 1, the output, that is the sum, is 0 and carry is 1. So we can see this, the sum is 0 and the carry is 1. Similarly, 1 plus 1, the output is, that is the sum is 0, carry plus 1. Now again for these 3 cases, which is very unique, a plus b, that is 1 plus 1, the output is 0 and carry is 1. Okay, again the carry output, that is the sum is 0, is added to 1. 0 plus 1, which gives the sum as 1, and since we had the previous carry of this a plus b, we can write it down as a plus b, that is the sum is 1 and the carry is 0. So now let's move on to the another topic, or the another type of circuit. Before moving to this, let's check out the circuit diagram or the logical diagram for half adder. The half adder can also be written as, like, if we have a 3 input half adder, that is A, B, C. So from sum and carry table, we can check out this. If we make a K map for sum and if we make a K map for carry, we get the equation for sum as sum s is equal to A XOR B XOR C. Similarly, if we make the K map for the carry, we get the output as, or the equation as, AB plus BC plus AC. This is the equation for carry and this is the equation for sum. Let's move to the other topic, binary adder. Okay, the binary adder is the same way it works like the half adder or the full adder. A binary adder is a digital circuit that produces the arithmetic sum of 2 binary numbers at a time. It can also construct by cascading number of full adders. We get n-bit binary adders. That is, if we cascade more than 2 or multiple number of adders, we get n-bit binary adders plus. The n-bit binary adders require n full adders with each output carry connected to the input carry to the next full adder. I'll explain this with the help of a circuit diagram. This binary adder is also called as a parallel adders. So I'll show you the circuit diagram of how the binary adders or the parallel adders work. Let's see the circuit diagram for the binary adders. Here it's given. A 4-bit binary adders. We can check out. These are the 2 numbers A, B. The sum is given and the previous carry. Okay. Similarly, as we can see here, it is also having a previous carry. So the output consists of the addition of A plus B, that is the inputs A0 plus B0 plus the carry. So the addition of these 3 gives the sum as the output, and the carry of these 3 numbers A, B and C is added to the next stage. Similarly, we can check out for this stage A1, B1, C1. The output, that is the S1 for this bit, for this 1 bit full adder, for 1 bit full adder, is A1 plus B1 plus C1, and the output is S1. S1 plus, if there is a carry C2, it goes into the next stage. Similarly is the working for this 1-bit full adder, that is A2 plus B2 plus C2, that is the carry of the previous stage. It gives the addition as S2, and if the carry exists, that is if there is 1 in the carry, the 1 as a C3 goes into the next stage. The same is the working for this. So here it's explained clearly with the example. AUGENT, let us say what AUGENT is. AUGENT is A, addend is B, that is A is AUGENT and B is addend, which means B is added to A. The number which is to be added to the number is called addend, and the number which has a number to be added to is called AUGENT. In this case, A is the AUGENT, B is the addend, S0 gives sum, C gives carry. Let us take the example AUGENT, that is A is 0 1 1 0, addend B is A is 1 0 1 1, B is 0 0 1 1. So let's work out. That is A0 plus B0. A0 is 1, B0 is 1. 1 plus 1, it gives 0, and the carry is 1. That is C1 is 1 here. Now this C1, as we can see from the logical diagram, this C1 goes into the next stage. That is, this C1 goes into this stage. This C1 is added with A1, B1 and C1. We can check out here. This is A1, this is B1, this is C1. That is the carry of the previous state. We get the output as 1, that is the sum as 1, and again the carry is 1. So this carry again goes into the next stage as C2, and it gets added again with A2, B2, and so we get the carry here, sum 1, and the carry goes again, and so is the working. So in short, if we go through the addition process, we can say the addition goes like this. If there are odd number of ones, like for example, if odd ones are present, then addition will be 1 plus 1 plus 1, the sum will be 1 and carry will be 1. Okay, if there are even number of ones, okay, even ones, that is if 1 plus 1, the sum will be 0 and carry is 1. This is a very important shortcut to work out the addition. Once we know the shortcut, we can definitely work out any number of ones. We just have to check out whether the number of ones are either even or odd. So to explain this, let us say example of 4 bits. 1 plus 1 plus 1 plus 1. Okay. Since these are even number of ones, the sum will be 0, carry will be 1. Similarly, if there are 5 number of ones, 1 plus 1 plus 1 plus 1 plus 1, the sum will be 1, carry will be binary subtractor. Binary subtractor works the same way like binary adder.